Good morning to all of you. Today is I will take your third lecture in your on optical fiber communication system. So in third lecture, my main agenda is window techniques. Window techniques is really important for optical communication system, and this window techniques is directly related to your previous class, that is directly related with attenuations, right? Attenuations. And if the time permits, then I will also include in this lecture is construction of fiber. Construction of fiber, right? So this is the two agenda I will try to cover this lecture. So first one is the window techniques. So before window techniques, I will explain some the types of communication media. Those are already we are using. In first lecture, I already told about your twisted pair communication. And second one is coaxial cable. Coaxial cable communications. And third one is no doubt already told, satellite communications. And fourth one is your optical fiber communication, right? Optical fiber communication. So as far as the twisted pair, name itself, the constructions is look like this, right? And if symmetry, coaxial cable, and this one is ground, right? And satellite and optical fiber communications. Optical fiber, I will describe in details the constructions. This is the core, the cladding, and here shielding. And as far as the satellite communications, satellite is based on triangulation law. They will monitor any device, any things, right, on the triangulation law. This is really important. Always remember that. Triangulation law. What is the triangulation law? You can already read in your satellite communication system, but how they work, let us do that one by one. Right. So first I will describe the twisted pair cable. Some symmetry. Please write in a symmetry way. Look like this. This is the actual combination of twisted pair. Now see. Twisted, two wires is twisted in such a way, right? But what is the disadvantage here? There is a electromagnetic loss. In twisted pair cables, electromagnetic induction loss is appeared. So due to this loss, this is EMI loss, the data rate support is very low, very low. So twisted pair cables, since data rate is very low, so where will these twisted pair will be used? So in telephone lines, we are using this twisted pair. So what is the disadvantage of main disadvantage? EMI. So this EMI loss can be overcome by coaxial cables. Here. Since this loss will be confined along the axis, right, and due to this ground, so all the loss will be confined along the axis. So here this is the advantage: low EMI loss, or very lesser loss is associated in this case. Second one, in coaxial cables, data rate support is high. Due to loss is this. So data rate high. So we can use LAN cable. We are using coaxial cables, right? So local area network, we are trying to use this coaxial cables. Now at the same time, satellite, first we'll see the satellite. Let us assume that A, B, C, the satellite will communicate to each other as a communication on the basis of triangulation law. Let us assume that this is the area where how the satellite will be worked. So let us assume that here is the tank. Tank will move towards our Indian territory border. So how they can trace? So satellite will be always monitoring with the Doppler shift. Doppler shift. What is the Doppler shift? If there is a movement in upward and backward, right? There is a apparent shift in frequency. B minus B dash by B plus B dash into mu. Mu is the frequency, B is the velocity. So if the velocity will be, if they will move here or move here, so relative velocity will be here maybe B minus B dash by B plus minus B dash, right, into B. So now B dash will change, right? Dash will change. Once the V dash will change, satellite will observe there is a some apparent shift, right? So once the apparent shift will appear, they are able to trace. So this is the really good communications for defense sector or any type of communication. But I already told there is a big disadvantage associated with this is cost, and a special set is required, right? A special set is required for communications, and most disadvantage is lifetime of the satellite, 6 to 7 years, right? So no doubt this is a really good communication, but I already told this is the complementary of the communication system, not a competition for the optical fiber, right? So always remember how any device has been traced by satellite communication by triangulation law, by the apparent shift. This is really very few people are knowing how the satellite will trace the tank will shift, or any plane will be moved from here to there through this Doppler shift, right? So Doppler shift is nothing but just the frequency shift, right? Due to this velocity, either upward or downward, the velocity will change, so frequency will change. So through change of the apparent shift, apparent frequency change, you can able to trace. Now last one is the optical fiber communications, right? So optical fiber communication, before we proceed optical fiber communication system, I will show the basic structure of the optical fiber communication, right? So then we will move, because then both are related to each other. So now I will explain first the constructions. So in optical fiber communication system, inner part is known as core, outer part is known as cladding, right? Outer part is cladding. This is cladding, this is core, right? Same cladding. Now here this is the shielding. What is the shielding will do? So if let us assume that in hilly area optical fiber is going on, pass through A to B positions, and suddenly the displacement of the hilly area, they will protect, or any pressure, if there any pressure, right, the displacement by hilly area, they will try to manage this core, because if they will not protect, shielding will not protect, then fiber will be bent, right? Then fiber will be look like this, right? And fiber look like this here. So what happened? Loss will appear, because optical fiber communication, how they will work, there is a one phenomena known as total internal reflections. I will explain in detail, right? This is very important. In any interview, first question is, can you please explain on which phenomena optical fiber works? That is total internal reflections, and this is totally depends on critical angle, right? Critical angle. I will explain later, don't worry. in the fourth lecture. I will explain this. So, so once if the shielding wind is not there, not protected, this will bend. If this will bend, so losses will appear, right? Loss will be appear. So, and since this loss appeared due to bending of the fiber, it is known as bending loss. Bending loss, right? Bending loss. Sometimes due to high pressure, there is a cut appears in the optical fiber. In that case, again loss. And after that, if the cut will appear, then we will do coupling the fiber, right? And coupling is the phenomena when two mode field diameter will be combined, so that loss can be minimized through the splicing technique, and that loss is due to the coupling, so that is known as coupling loss. I will explain later. This is not a right time to explain bending loss and coupling loss, but this is the phenomena. So how this core cladding, what is the core cladding, what is the shielding is really important. So core and cladding is the really important for total internal reflections, right? So for total internal reflection, core and cladding factor is very, very important. So every time the first question asked in optical communication system is which phenomena optical fiber communication is based, is total internal reflection. But second question is at the same time, what is the refractive index of core and what is the refractive index of cladding? Because you know that since in 9th class or 8th class you are knowing if the refractive index mu1, this is refractive index mu2, and if the tensor mu2 is greater than mu1, so it will move towards the normal. But if mu2 is less than mu1, then it moves towards away from the normal. This is the basic concept. And since when this will be 90 degree and greater than critical angle, then they will be moves towards here. So if the light will moves here and look like this, so now light will be travel look like this. So I will explain later phase. But this is the basic concept. I think we already studied in class 7 or 8, right? But here, the first question is, so for TIR, the question is which phenomena? TIR. So for TIR, core and cladding refractive index should be different. Understood? Right? Without, if the both the refractive index is same, then they will travel in a straight path, right? They will straight path, right? But as far as already told, how they will in optical communication system or in rays communications, they will move away closer to normal, away to normal. I think you understood now, right? Now, how we can remember cladding refractive index is greater than core or core refractive index is greater than cladding? This is really confusion for everyone, right? So always remember that this will be revert back only when this refractive index mu2, this is mu1, let us assume that this is mu2. So sorry, mu1, cladding, so mu1, cladding, core is mu2. Sometimes let us assume that this is n1, this is n2, this is n2, right? N2. So n1 is greater than n2. So first condition is core refractive index is greater than cladding refractive index. This is really important. Please remember this always. But at the very easy. But at the time of interview, should forgotten or some confusion. अरे यार कोड का होता ज़्यादा cladding होता है. So I am again giving the practical conditions, right? Giving the practical examples. Please don't remember this. See how we can remember throughout the life. So see here, you can remember without any concern, without referring anything. Always remember this. And no very few books has mentioned this concept. So now see how you can remember. Since we know refractive index of core mu1, this is mu2, this is mu2. For TIR, we know that mu1 is greater than mu2, right? for TIR, mu1 is greater than mu2. So how we can remember? So always symmetric please. Right. Now see, this refractive index is higher. Why higher? So always remember that SiO2 plus GeO2, gallium oxide and silicon oxide. But here, composition of the construction of the optical fiber is core is made up with the SiO2 plus GeO2, but cladding is made up with only SiO2. So hence here are two materials, so should be diffractive index mu1 is higher than mu2, because here the two materials, here the single material. So throughout the life, no one will tell you why core refractive index is higher higher than the cladding. Yes, they will tell for the TIR, core refractive index is required to higher the cladding, but no one given the actual practical conditions, right? So here the basics you always remember. Since here the combination of both two materials, so no doubt two materials. So should be this refractive index will be higher as compared to cladding, right? So today my two agenda. In one agenda is construction of fiber, no doubt. Here again sealing, and sealing you will be protect from any types of damage, external damage, bending loss. They can protect from the coupling loss, different types of at the same time, I will give the one best example about this one. In 2012, near about 10 or 11, there is a fiber cut in the sea, right? In the sea, and due to the fiber cuts on the sea, the entire India backbone will be damaged, and due to this backbone damage, the entire internet will goes down, and not for 1 day. I think 7 to 8 days our internet has gone down because due to the damage of this optical fiber, since the optical fiber is also moves in the sea also. Currently our Prime Minister has launched in the same optical fiber in the Mandeep, I think Andaman Nicobar, right? So the same currently Singapore to Abu Dhabi to Dubai to India, and different types of optical fiber had deployed through sea also. So if the optical fiber in the sea, if the optical fiber cut is there, then again which type of loss? Coupling loss is there, and once the coupling loss is there, then your backbone is down, and once your backbone down, your entire network will be goes down. So I think for the wireless, wired, any networks, optical fiber is the backbone. So this is the construction. So just refer this concept. There just now we have observed the concept regarding the constructions of the optical fiber is depends on core and cladding. For the TIR, no doubt, core refractive index is greater than cladding. But why? Because core is constructed with the SiO2 plus GeO2, but cladding is constructed with the SiO2 only, right? And second one, the types of communications. Always remember, this is really good concept, and if you are not referred some satellite communication concept, this is really good concept regarding how satellite will trace the locations and how they can trace the actual enemy positions, right? And same the coaxial cable and twisted pair cable, there is their own advantage or disadvantage. Now finally I will compare with optical fiber and satellite communications, right? So just see, just draw one table, left side right satellite communications, or right side optical fiber communication, or vice versa. What you can want to do, please draw one table. So here in satellite, write down satellite communication. satellite communications, and second one is optical fiber communication, right? OFC. So serial number 1, 2, 3, right? Serial number 1, 2, 3, 1, 2, 3. Please, I already told many advantages. Please ask, tell me first, what is the first comparison? So lifetime, right? Lifetime. First serial number lifetime. What is the lifetime? 6 to 7 years, right? It is a long life, maybe 60 to 100 years or more than that. Right? So first one is the no doubt lifetime. Yes, this is one very good concept. This can be used for point to point and point to multi-point communication. But this is one disadvantage, point to point communications. But yes, through backbone, through router and base stations, you can communicate with the. This can be also possible through optical fiber communication. But generally, this is the point to multi-point communication can be possible. But here, point to point communications can be possible, right? So, third one, as far as the bandwidth concerned, no doubt bandwidth is lesser than optical fiber communications, higher bandwidth. I already told very large bandwidth will support by your optical fiber communications, right? And but one thing is important, good in satellite. Once you have launched the satellite, maintenance is very difficult to maintain the satellite, right? So this is maintenance free. But here is maintenance is required. Maintenance is required because sometimes bending loss is there, coupling loss is there. You should maintain the loss due to the by the help of coupling splicing techniques. You can reduce the coupling loss. Right, so so in the case of optical fiber, yes, maintenance is required, but in the case of satellite, maintenance free can be there, right? So this is the first today's agenda. I have already covered regarding the construction of the optical fiber, right? So I have just summarized the construction of the optical fiber is core, cladding, and shielding. Core is made up with the SiO2 plus CO2. And cladding is made up with the SiO2 only. That's why core refractive index is higher than cladding, and that is the condition for total internal reflection. So question is, if anyone asks which phenomena optical fiber communication is based on, so total internal reflection, and total reflection is fulfilled by core and cladding because core refractive index is higher than cladding. As far as the types of communication system, yes, coaxial cable, twisted pair, satellite, and optical fiber all have their own advantage. But yes, coaxial cable have some limitations. They can be used only for the telephone lines. Coaxial cable can be used for LAN purpose, but for the metro communication, for highway communication, let us want to communicate from SMBDU to IIT Jammu to Delhi. For that one, optical fiber is the best or suitable candidate for the long range communication system for highway communications, right? At the same time, satellites have own advantage for point to multi-point communications, but the cost associated with this satellite communication is very costly as compared to this. But yes, for the tracing of for the defense sector, it's really good communication system, right? Now I will move towards today's second agenda, and that is known as Windows techniques, right? Windows techniques. So now I will explain the window techniques. Window techniques is nothing but let us assume that if you want to someone is cross in a lane, and you just watch from your window, and in your flat or at your home there are 3 windows, and you want to continuously watch the persons they are passing through the lane. So first you will see the first window, then you will see the first part, then again you move towards the second window, you will see the second part, and continuously the third, right? And as far as the window techniques related with the optical fiber communications, there are 3 windows associated with the optical fiber communication system, and that is totally related with the attenuations. So how, before we explain further, I just want to relate the real-time scenario of the window techniques. So since we know that optical fiber is totally based on the wavelength. If the wavelength is increases, since I already explained, if the wavelength is increases, the frequency is decreases, right? Frequency relation is decreases, it's just inverse. So in window techniques, there are 3 types of windows has been proposed for different type of attenuations. So here I will just draw the windows, different types of windows, and different windows have different purpose and advantage. This is the wavelength, right? And y-axis is attenuations. Attenuation is nothing but the reduction of power. Already told, 10 dB P by 10, 20 dB P by 100, 30 dB P by 1000. So reduction in attenuation. So attenuation is always in dB, right? So before we proceed further, attenuations is nothing but it is the intrinsic properties. Why? Because how the attenuation will be appeared in the fiber. So before we proceed further, let us assume that is the core. This is the core of the fiber, and let us assume that this is the impurities inside the glass. Right? This is the glass. So what happened? Due to this impurities, attenuation can be increased. Right? Attenuation can be increased due to these properties. Because since this is consist with the silica is will find in abundant nature, and there is a chance of there is some impurity inside this glass. Right? So let us assume this is an impurities inside the glass. Right? Now what happened? This impurities may be a cause of attenuations, and silica have sometimes with some water molecules also, right? Water molecules also. That means this will also constitute the OH minus ions, right? OH minus ions. So now light will be entered in this glass, and through some angle, through TIR, they will travel from A to B. Through this journey, let us assume that this impurity will be impact on this fiber, on this light. Due to this impurities, your power factor can be reduced by this, or any factor can be appeared. Now see, in the same time, maybe OH minus ions will be appeared. So once OH minus ions is hydroxyl ions, and they will should absorb the light, right? And due to the absorption of light, the attenuation will be increased. Suddenly, light will look like this, but suddenly attenuation, initially attenuation behavior like this, but as soon as OH minus appeared, they will increase it, right? Second thing, the silica, due to the silica, so the question being asked is, which type of property is associated with this class? So since impurities is itself found in the material, in the glass material, right? So internal properties, right? So impurities itself properties, own properties associated with this glass. So this type of material is known as this type of property is known as intrinsic properties. Intrinsic. If always remember, if some external factor will be responsible, that is known as extrinsic. But since here, due to silica impurities, attenuation will increase, so itself properties, right? Scientists have found that the impurities itself with the silica. So this impurity is known as intrinsic property, right? Intrinsic materials, right? And so intrinsic properties is there. So due to intrinsic properties, attenuation will be high. At the same time, silica is okay, intrinsic properties, attenuation is high, but at the same time, if the OH minus will be appeared across this silica, because sand absorbs the water molecules very easily and very difficult to segregate. So OH minus ions is again, the very dangerous factor who appears along the fiber in the form of attenuations, right? So consideration of this intrinsic properties and OH minus ions, in the next class I will draw the spectra of window, right? A spectra of window, that is the window techniques. In window techniques, we'll explain how many window. 3 window is associated with the optical fiber communication system. So in the next class, I will explain the window techniques associated with the optical fiber communication system. So now I'm here in this lecture 3. I am concluding. In this lecture, you are able to understood types of communication system and the construction of the optical fiber. So hopefully you understood the basic concept of both of this concept, and I will continue this concept in lecture number 4. Thank you.